Hey folks, welcome to the first ever digital Learn Swift Boston. This is a little bit different from us. We are normally a meetup that meets in person, but given how things are going with COVID-19, we're going to do it a little bit differently. So if you aren't familiar with who we are a meetup here in Boston, Massachusetts, and we are part of the Learn Swift City group of meetups. This started with one man from the LA area. He was a lawyer. He decided he no longer wanted to be a lawyer, so he quit his job, started driving Uber so he could teach himself Swift. Started a meetup just like this out in LA called Learn Swift LA. Started a podcast and reached out to the internet saying, hey, if you want to start a meetup in your hometown, let me know. I did, and here we are almost 4 years later talking about Swift, and first time ever on the internet. So we usually have a schedule. It's going to be much different today. We start out with introductions and announcements, which you can see we're about 10 minutes behind of due to some technical issues, but we'll get back on track. And then today we're going to talk about concurrency. I have Zev on the call, and he's going to teach us all about some real-world applications of concurrency using Swift for iOS. So the only introduction that we'd like to do tonight, since we are going full digital, is if you're in Twitch chat or in our Slack group, just let us know the next thing you want to learn. That helps us out planning all of our meetups. This session about concurrency actually came from a meetup. A bunch of people were talking about what is this multi-threading? What is concurrency? What do these words mean? Is this something I need to know? And we would just like to know what you want to learn so that we can make sure that we're providing good meetups and maybe even another streamed meetup, depending on how vaccines and weather and things go. So if you have anything you'd like to learn, just post that in either our Slack group or in Twitch chat, and we will keep track of that. We also have a sister meetup, which, Zev, if you'd like to unmute yourself.
Aha, I found the button. Yes, we have Swift Coders, which usually meets at Rightpoint, although at present I'm exploring options for hosting it virtually for probably the next session, maybe two. We'll see how it goes. But Swift Coders is typically a more sort of informal format, or we would just kind of hang out. There's some food. We chat about Swift and iOS development in the community and whatever else is going on. For the next remote one, I'm thinking of doing some sort of Q&A type format. So stay tuned for that. If you go to the meetup page, I'll be posting announcements and things.
Cool. So if you take a picture of that QR code, you'll get a direct link to the meetup page for Swift Coders Boston. We are also a Ray Wenderlich affiliate. So if you are interested in learning some Swift and you need some help, whether through a book or their online tutorials, you can take a picture of this QR code, and anything you buy from that web session will give us a small percentage of the sales, and it helps fuel our meetup. Those are our announcements. And so I will quickly switch over and stop having my camera on so you can see Zev when he is talking. And we're going to talk about some concurrency stuff.
Cool. Ready to go? So I have a repository up. If you're interested in following along locally, I'm posting the link into the chat. And you're going to want to be, if you want to follow along, the master branch is like the final state. But there's a pre-meetup state branch that I've also posted in the chat. And if you go to that branch, then you'll be where I am at my starting place, if you want to follow. And this is based on some questions that people posted and asked us when we ask what things do you want to learn next. And concurrency and parallel processing came up a lot, and we've been trying to dig into what are the real world use cases, because there's a lot of esoteric or I don't know if esoteric is the right word, but there's a lot of use cases for things like concurrency and parallel processing that you would learn about in like some sort of operating systems class or something like that. And that's not what I'm going to be talking about, mostly because I don't know that stuff because I never took an operating systems class. What I'm going to be talking about are a couple of like the really common real world use cases for where you would actually encounter topics around concurrency in sort of day-to-day iOS programming. To that end, we have a little server that I'll show you how to get up and running, and then some documented API endpoints, and we're going to just talk about hitting some API endpoints. We figure for the first two examples, networking is probably far and away the most common use case for concurrency on iOS. To show you what we'll be building on the repo, I'm going to go in, I should be on the pre-meet upstate branch. I'm going to go into the server folder. So there's an iOS folder and a server folder. Matt was kind enough to throw together a server in Vapor, which is a server-side Swift framework for building servers in Swift. So we have a little server that we're actually going to run locally on the computer, just so we're not worrying about, the real network and its reliability right now. So if we go into the server folder and go into the main README, gives some steps for setting up the server, which we can run through if we want. I've already done it on my computer, so it would basically take 0 seconds. It'll take a little longer on your machine. So
yeah, I don't think we need to set it up
okay.
again, but if anyone has any questions about it, I am monitoring both Twitch chat and our Slack, so I can both ask questions to you, Zev, for the community, but also I can answer questions about the server as well.
Cool. Yeah, so suffice to say you have the server installed. And if we go into the documentation folder here and go to endpoints, Matt wrote up some lovely API documentation. So our first example is an API endpoint. So it's an address out on the internet, or in this case on our local server, and it lets us retrieve a quote. And I can open up this example response and see that it's going to give us some JSON that's got a quote and then an author. So we're going to be in the little sample app that I've built here. We've got the networking example, and I'm going to click get quote, and it will go and get the quote, except right now it doesn't do anything because the app is empty. And then the second example, well, we'll get to the second example. It gets more complex from here, but let's start with the basics. So I'll show you how I got here. So in the folder for the project, I've opened up the iOS folder, and then get stuff is the name of the app. And then there's an Xcode project in there. So I'm opening up that Xcode project in Xcode. And we have some models that just define, they're basically the same as that JSON that Matt had in the README. So we're just dealing with the quote here. These other models are for later examples. So we have our quote and our author, and it's decodable. So we'll be able to convert this from JSON. And then we have an API client. And there's a million different ways you could write this. I wrote a very simple one. And this is a type where we're going to ask it, hey, can you go get me some quotes? And it's going to give us back quotes. And we'll talk about how that works. And then we have a view controller. And this view controller is hooked up to a storyboard, as you might expect. And it's just got some fun little typography, and it has a place for the quote and the credit for the quote. And then it has a little spinner, and we're going to be showing and hiding that spinner to show that it's loading. But before I do any of that, let me get the server running. So I'm going to go into the server folder, into concurrency server. And this is pretty neat. This is a new feature of Xcode 11. I can grab this package.swift file and open it right in Xcode. There's actually no Xcode project. I can just open the package.swift directly. And when I do that, you can see Xcode is going and figuring out all the dependencies and resolving them and getting everything that it needs to be able to run this server. Hopefully in a couple of years, we'll be fully on this and not needing to mess with CocoaPods and all that stuff. Maybe, we'll see. So as soon as those are done, it takes a little bit because Vapor has a lot of dependencies. Okay, so now I can choose the run scheme, which I think is the default, and choose to run it on my Mac and hit run. And then we should see if everything is working. This will build and run, and I'll have a server running, and I can actually test it in the browser, which we'll see in a second. That build took longer than I thought. Okay, there we go. It's done building, and we'll see some logs here when the server's running. Okay, cool. So server starting on localhost :8080. So if I copy that address and go into Safari and paste it, we'll get this little "it works" message. So that's great, but we're trying to hit an API here. So I'm going back to the documentation, and it looks like if I make a GET request to /quote, we'll get a quote. So let me test that out in the browser. Localhost /quote, and it looks like it's taking a second. Matt actually put in an artificial 5-second delay. So there's literally some code in quote controller that just sleep 5 that just causes it to wait 5 seconds. And we did that intentionally so that it would seem like the server was slow, because most servers are, so that you can build the app and make sure it works with a slow server. If it does, it will probably work with a fast server. Also, one quick note, I'm in Safari here, and I have an extension installed called, I don't know what it's called, JSON peep, and it just formats the JSON nicely so I can look at it. So it's a fun little tip, JSON peep. So anyway, there's a quote, and if I refresh it and we wait 5 seconds, I might turn that 5-second wait down a little bit once we get the idea. There's a new quote. So, okay, we're going to keep refreshing this, and it'll keep giving us different quotes each time. Cool. So that's the server. And so the basic idea is I need, here's the handler for when I click this get quote button. And we need to do something that will cause the app to go out to the network and get the quote and then display it in the app. So to do that, we actually have the API client with the method stubbed out already. So if we review what that was, API client has a static function get quotes, and it takes a completion closure that gives us back a result that's either a quote if we got one, or an error if something went wrong. And so we have to implement this method and then call it in the view controller. So I'm going to, I think I'll implement this method first, just to sort of satisfy this contract of, once it's done, I will call this completion handler. And feel free, I'm going to be using some jargon here, and let me know in the chat what's clear, what's not clear, if there's anything I can clarify. So we're going to be using URL session for this. You might see people using LMFire, and that's fine, but it's often overkill. URL session is pretty capable these days and is a good first place to look for basic networking needs on iOS. So the first thing I need is a URL. I have my base URL. I know that whatever I request, it's going to start with http://localhost:8080. And then I'll be appending things to it. And if we remember from our API documentation, it was /quote. So that's what I'm going to be doing. I'm going to do let URL equals my local server URL, appending a path component of quote. And that appending path component will give me the /quote the way I want it. And then I'm going to make a request. So URL session, just get the shared default session. You could use your own session if you were doing something more complicated. And there's a whole bunch of different things it can do. I'm going to ask it for a data task. So data task is the object that sort of encapsulates the idea of a request that's running. And I'm going to get a data task that also gives me a completion handler, so I get a chance to look at the result when it comes back. And it takes URL, so I'll give it my URL. And then I'll hit return on this completion handler, and that will fill in the things. So now we play a little bit of Mad Libs, data, response, and error. And annoying Xcode, you can't option click these to get the type, but if I put them in here, you can see the types. Go figure. So data is an optional data. So if data came back, it will be there. Response is an optional response. So that hopefully will tell us what if the result came back, a bunch of information about it, like the response code and that kind of thing. And if there was an error, that will go here. so we need to somehow transform those things into this result here. Let's see, I'm gonna do this. Yeah, I'm gonna call the completion here. Keep in mind that this is a talk all about concurrency. So where does the concurrency come in? Well, it looks like I'm just running these lines of code right after the other. So like, you know, if I do print hello here, it looks like that would just run immediately after line 28. But this these curly braces indicate that I'm now inside a closure, which is basically you take some code, you bundle it up inside some curly braces, and that code can be sent off somewhere, held onto for a while, maybe called later. So it's a way to take code and kind of bundle it up and pass it around. And so even though the line line 29 comes right after line 28, it's not going to be called right after 28. 28 is going to be called, and then we're on to the next thing. If I do, this will get printed first. This will get printed second. So that's surprising if you're not used to concurrency. That's a little weird. Or maybe not concurrency, maybe asynchronicity is the right term here, that these lines are not just running one after the other. This one, everything between these curly braces is getting saved off and then run when the request comes back. Okay, enough talking around the issue. Let me actually write some code. So we're gonna see if we have data. So if let data equals data, so we're gonna unwrap that. So if we have data, great, we can call our completion handler. But there's one more step we need to do, which is this is a quote, and what we have right now is data. So we need to decode that data, which hopefully is JSON. So the way we would typically do that, we have a JSON decoder here. So I'm going to do let decoded equals, or let's say let quote equals decoder dot decode. Give me a quote, please, from the data. And that's going to be a little grumpy because it wants to be able to throw an error, and it's not inside a do catch block right now. But that's okay because I'm about to wrap it in a result, and a result can actually grab that error for us. So I'm going to pretend this line is okay. You'll see why in a second. And I'm going to try calling our completion handler. So remember, this was the closure that was passed into this function, and it's saying, hey, please go get me some quotes. Should really be get quote. Please go get me a quote. And then when you're done, call this function, call whatever I handed you. So I'm going to call that completion, and it takes a result. And I guess I should just real quickly go over result. Result is a type provided by the Swift standard library, and it's an enum that can be either a success, meaning it will actually give you back the value, or a failure, and it will give you some error explaining why it failed. So it's a way to encapsulate the idea of give me back the success or the thing that went wrong, and that you'll see these a lot in sort of networking or sort of any failable operation. So I'm going to call my completion, and it expects a result. So I'll make a new result. And result has this neat initializer, which is catching, and it will catch a closure that throws something. So I can make a closure here, and in there I can try my decoding. Just put that right in there. So now that method that was complaining that it wasn't happy because it wasn't inside a do, I've sort of kicked it up a rung by saying, well, now you can just be caught by the result. And so if this works, great, it will become a result.success. But if it fails, then the fact that it failed will be captured in this result. And the thing that this gets passed back to will go, oh, look, I've got a result. It has an error, and it will have presumably some decoding error. Feel free to post questions in the chat. I know that was kind of a lot all at once. I'll see what I can do about clarifying anything. So that's if everything worked, if we got an actual data back from the network. But what if the network request itself failed? Well, we have to handle that as well. So else we're going to caller completion. We know we're going to be some kind of failure. So this is, I'm using type inference here, but this is actually a result.failure. And it will be the error if we got it, if we got one back. But if for some weird reason it failed and didn't give us an error, then we're just going to give it, I made a little dummy unknown error type just to handle that case. I'm just going to say, at least tell me that we had some unknown error and we were trying to fetch this URL when it happened. And here's the response we got back in case it helps figure out what went wrong. It's just sort of a weird catch-all. And then the thing that trips everybody up, and I probably lost at least 10 minutes trying to debug this when I was writing this the other night, is that when you make a URL session data task, you have to call resume on it or it will just sit there not running.
Yeah, so, I can't tell you how many times, even on stream, that I forgot to add the resume. I'm just, why is this not working?
It's rough. There should be like a forgot to call resume. Yeah. Ooh, we have a question from the chat, which is, can we simulate an error from the server? Yes, good idea. We can. We'll do that and make sure that our success and error cases are both working correctly. Okay, so we have our API client method written. So now let's use it. So I'll go to my networking view controller, which is just what I called. Like, that name doesn't really make sense in an app other than this is the app where I'm demonstrating basic networking. And we have this method here, get quote tapped, so that we click the button. So the basic idea is we want to do a couple things. We want to put the, oh hey, my break timer's on. Put the UI in a loading state. So like the spinner will spin. And then make the request, and then handle the response. And that will include 3A handle success and 3B handle failure. So those are the basic steps we're going to do. Now I just have to go and fill in the blanks. So put the UI in a loading state. Let's see, I've got, I want to disable the button so that you can't accidentally click it twice. This is a super common mistake, and it's especially scary in like an e-commerce app, because you could click the checkout button, and then while it's loading, you could click it again, and like, what happens there? That's bad. So just the very first thing we're going to do is set is user interaction enabled to false. Ooh, and I guess down here, either way, whether we handle success or failure, re-enable the button so we can click again. We'll have to remember to do that, which is annoying, but we'll do it. Okay, so I disabled the button, so it'll be disabled for the whole duration of while this thing is loading. And then I have this stack view that contains the quote, and I'm gonna set the alpha to 0, so it's invisible during loading. I'm not making it hidden. Oh wait, the thing I was about to say is invalid. Ignore what I was just saying.
Zev, we have a question in chat. Do you normally do the pseudocode, or are you doing that just for the stream tonight?
Yeah, that's a great question. It depends on the complexity of the thing I'm doing. So for this one, because it's a fairly routine example that I've done a lot of times before, I didn't do pseudocode, although I'm sure I did when I was learning this kind of thing. But for anything that's even a little bit complex, or where I know I need to do some steps and I don't know exactly what they're going to be, I definitely do pseudocode. I'll often not with the numbers, but like, you know, somewhere here I'll do like to do reset the what's it, and then that will show up in my pull request if I forget to go and do it. Hopefully a code reviewer will flag it, or you can turn on like warnings for to-dos and make sure you grab it. So I leave notes for myself all over the code and then go clean them up before I finish you know, a feature or something. Often also I'll do this, but not in code. I'll do it on paper. So I'll literally draw myself a little diagram of what things need to happen in what order. So yeah, it's a great habit to get into.
I do it a lot too when I'm working with other people, because when you're talking to someone about the code, you tend to go down rabbit holes and sidetracks, and so having those comments are good to help you remember what your next step is.
Yeah, definitely. And like I'm gonna leave it in here because then you'll be able to see what each section does. It's I picked it up as a habit for sample code from Ray Wenderlich, which does they always do these little numbered sections because then I can say like, look at section 2. So that's a good thing for communicating, as Matt said. All right. So I set the quote stack alpha to 0, and I remember why I was going to do this because when the thing loads, I want to do a nice little fade in animation just as a fun adornment. And then I'm going to ask my spinner to start animating. And I've checked the option. There's a thing in the storyboard on the spinner that's like hides when stopped. So I can just ask it to start and stop. And when I do that, it will automatically hide and show, which is just a nice little convenience. That should be the default. Okay, so I've asked my spinner to start animating. And so that's there. I'm done putting the UI in the loading state. And we can actually check that. So I'm going to run it. And I'll click get quote. And we just get infinite loading state. This will never stop. So let's proceed quickly on to the next step. So make the request. This is the kind of the meat of it. This is why we're all here. I'm going to ask my API client to get quotes. And it's prompting us to fill in a completion. So I'll hit return. And I'll just name this parameter result. And we don't need those parentheses. So I'm asking it to get quotes, and it's going to give me back some result. And I'm going to do some stuff. So this is now, all of this stuff actually happens inside here. So that means I've actually finished the request. And just to show you that I've finished it, I'm going to print out the result, and let's run it and see what happens. So the screen won't get out of, I'm not doing any of these. I'm not handling success and failure, any of that, but we will print out the result that we get. So I'm going to hit get quote, and there, we got a quote, and it printed success. Somebody asked about simulating an error. Oh, not Safari. So if I go into the server code and let's see, I'm going to make this like 2 seconds just because 5 is long if we're going to keep testing this. Wait, how is random quote not in? Who's calling this?
It's set up as a controller somewhere. If you go, you're searching just in the package.
Oh,
yeah.
I was looking for the, I had a curly brace and it's not used here. I actually don't know how I would throw an error.
The random quote function is throwable. I've not gotten as far as how to do errors in Vapor because I'm just learning it myself. But I would imagine if you throw some error, it would definitely return it maybe.
Cool, let's try that. I have no idea if this will work, so we're learning together. Throw some error, and I'll just run the server again and see what happens. Yeah, we don't know what's going to happen. Okay, and then if I run the app again, hey, cool, look, I got an error. So we got a failure. There was a Swift decoding error because we were looking for the key quote, and instead it didn't find a quote in the result. So whatever, I don't know what the server actually returned back, but it wasn't a quote, which is great. We've successfully simulated an error. So I'm going to comment that back out, but later when we get to error handling UI, I'll put it back in, and then we'll be able to simulate an error. So cool, and that was a great suggestion, Allegra44. Okay. So we know that a result is coming back. And just to kind of drive home the point about what order things happen in, I'm going to put a print. This will happen first. And inside here, instead of printing the result, I'm just going to print this will happen later. And let's just run it and see what happens. So this will happen first. This will happen later. So the code got to here. It said, oh, cool, a closure. I'm going to hang on to everything inside there, and I'll call it when the quote comes back. let me move right on to the next line of code. It calls this one. Then later, when the quote comes back, it calls everything that was in here, and so it ran this. Okay, so now we're going to handle the response. And so let's think about what we need to do. The response is a Swift result, which means it's either a failure or a success. So we're going to switch on the result. It's usually how you handle enums. And so if it's a success, then we're going to pull out the quote from the success. Then we're going to handle success. Oh, I can just do this. And if it's failure, let error, that's where we handle failure. And in either case, okay, let's see, this goes here. And in either case, we're going to have to re-enable the button at the end. So let's see, yes, I just need to put a break here until I actually write some real code. So handle success, what's that going to look like? Well, we want to set the text into the UI. So I have a quote label. I'm going to set its text to be the quote dot quote. That's the actual body of the quote. And the author label's text is going to be, I'm going to do a nice little m dash to do formatting quote dot author. So I'm interpolating the author into the string. So the string will be, dash space the author. And then for now, I'll just set the alpha back to 1, and then as a little cherry on top, I'll animate it. So quote stack dot alpha. So let me do to do animate alpha. Okay, so that would be the success case. We'll test that. Actually, I can test that now because we know it's going to work right now, and then I'll kick it over to error case and test an error. So I'll click get quote, and oh, okay. So this is the first little gotcha when you're doing any kind of asynchronous programming, and this is something you've probably heard things about. There's a lot of information. There's a lot of misinformation. Feel free to ask questions. I'll try to clarify what I can. We are talking about the main queue here. Xcode has gotten pretty good at telling you when you've made mistakes. It doesn't always tell you how to fix them, but you can at least see what happened. So UI label.text must be used from the main thread only. I feel like I may have said test, but I meant text. UI label.text must be used from the main thread only. And this is really common for UI things. So what is the main thread? So we have devices with many CPU cores or whole processors, and they can do multiple things at once. But there's always one sort of stream of work called the main thread, and it's the place where UI stuff happens. And so you always need to update text on the main thread. Or sorry, not update text, update any like UI thing, anything involving views and layout and that kind of thing. And when we did a networking event, you can actually see, if you look over here in the little debugging sidebar, we have a bunch of threads. So we have thread 1, that's the main thread. And if you pull this out, you can see com.apple.main thread. You can actually label threads. You can label queues. And so the main thread is currently running the main queue. We will get into the distinction between threads and queues a little bit. But when you kick off a networking event, it goes off and says, all right, main thread, keep doing what you're doing. I'm going to go over here on a separate thread on a separate CPU core. I'm not going to bother you. I'm going to do my thing. I'm going to hang out and wait for the network, whatever I have to do. But when it's done doing that, you can't just go and update the UI, because that has to happen on the main thread. So we need a way to jump back to the main thread. And Apple gives us a nice, fairly simple way of doing this, which is called dispatch queues. And I'm going to use probably the most common use of dispatch queues is this is coming back on some thread. Let me just get it back to the main queue. And so I'm going to do that by going dispatch queue.main.async and do all the rest of the stuff inside there on the main queue. And just to show you why we have to worry about this, if we go and look at the implementation of this data task, so I'm clicking option click on this data task method, it'll show us the documentation, completion handler, Let's see, does it say anything about what queue it comes back on? Let me bring up the full documentation. So I clicked, I option clicked on this, scroll down, open in developer documentation. Okay, the completion handler to call when the load request is complete. This handler is executed on the delegate queue. Okay, so this is like not clear at all from the documentation what you're supposed to do. When you're dealing with URL session, you can tell it which queue you want to use. But by default, it's just some random background queue. And so it's not making any guarantees that it will come back on the main queue. That seems like it's a sort of gap in documentation that maybe I should file a bug about. So this stuff is all going to be called on whatever queue URL session decides to call it on. And sometimes that's fine because sometimes you're going to take it and do other processing with it. But back out here, we want to put it on the main queue to do all our UI updating. So let me run that again. Now that we're on the main queue, and get quote. And now we have our queue. Aha. I found a bug. We have more things to do. In addition to re-enabling the button, we also need to get rid of loading state. So let's do that real quick. So re-enable the button will be what is it? Sender, right? It's just the button was passed to us. We can just use that again. The sender is user interaction enabled is true, and self.spinner.stop animating. From the chat, does that bring it back to the main queue after success? So what I'm doing, I'm putting all of this code on the main queue. I could put the dispatch main async inside here, and that would send just the success to the main queue. And maybe that's what I want, because maybe in the failure case, I want to go do some kind of retry or something that's on some different queue. But in my case, I want to do all my handling of everything on the main queue. So I'm just kicking back my entire success block to the main queue. So everything inside these curly braces is going to happen on the main queue. So the switch and then the updating of the UI and everything. So okay, let's make sure that my spinner goes away and my button is re-clickable. So if I click again, I'll get, yep, I get a new quote. Great, so that's actually working now. We just need to do our error handling. So there's a bunch of different things you can do for error handling. They're pretty much all terrible. You know, there's no great options when what really should have happened is your code should have worked or the network should have worked or whatever, you know, it should have gone right. So in this case, we're just going to show an alert, say, hey, sorry, that didn't work. So the way I'm going to do that is I'm going to print an error first. Error fetching quote. Just so, you know, in a real app, maybe you would send this to your logs. Maybe those would go to a server. Maybe you could use those to help track down errors. But I'm also going to show something a little more friendly to the user. So let alert, I'm going to make a UI alert controller and just pop up a little message. So I'm going to say error loading quote. Message will be the error's localized description, which will give us hopefully something useful. In our case, probably not. It'll just say something like decoding error, but it's the best we can do right now. Usually you want to spend a little more time figuring out like what is useful to tell the user, make it a little friendly, tell them what they can do about it. And then let's say that's an alert, and we're gonna add an action, which is just an OK button.
I think it's also important to call out that this is something else we're doing with the UI. And so if you didn't do the main queue over the entire switch statement and just for the individual cases, you would again have to do a main queue inside the failure. But because you're doing it around the entire switch, this is fine.
Absolutely. So I'm going to go and re-enable our little error on the server and rerun the server. If you were doing some real testing on a real server, you'd probably want to build yourself some endpoint that just gives you an error every time, so you can always test your errors. But let's get quote, and we're going to expect an error this time. Error loading quote, the data couldn't be read because it is missing, which like is kind of okay, right? It basically, what that translates to under the hood is the quote key was missing from the JSON, and like that's not a great error to show to a user, but for like 3 lines of code, it's not bad. So click OK, and then we also want to make sure that this stuff still happened. So indeed, I can re-click get quote as many times as I want, and if I unbreak the server, then without running the app, I should be able to get quote again. Oh, okay, cool. So I hit it while the server was in the middle of restarting, so could not connect to the server. That's another great error. And a good way to test, just take your server down. And then I'll click again, and this time we should get success. Hey, cool. So that's the first example. And that's, it covers a fair bit of ground, but this is like the 95% case of what you're gonna be doing with queuing and async stuff. So we talked about doing stuff in a closure with some bit of code that takes a closure and wants to go do stuff in the background, wrapping it up in a result, sending it back in the completion, and then taking the result and putting it on the main queue. And I could have put the main queue thing here. I could have just had, my API client always calls back on the main queue, and then usually you'd want to document like always goes to main queue or something like that. But often it's nice to leave the option if the person using the code wants to keep it on a background queue. So questions for that, and then we'll move on to the next example.
Chat, the questions have been great so far, so keep them coming.
Yeah, totally. Oh, I was going to do the little gravy on top, fade the animation, and we have gotten requests for animation. So just a fun little one-liner here. I can. There's a lot of properties in UIKit that you can just change inside an animation block, and they'll animate, which is cool. So I can just say UI view animate with duration. Let's do 0.3 seconds is usually a good default starting point, and then any code I put in here, if the property is animatable, like an alpha or a frame or position or anything like that, it will just animate. Let's see if that works. So once this finishes, I don't know if it will show over the stream, but I can assure you it is animating. Nice little fade in. Okay. So then the next thing I want to talk about is sort of the next most common thing I see and things I see questions about a lot, which is sometimes you're dealing with an API. Sometimes it's not the best designed API. Even well-designed ones sometimes run into this problem, which is that sometimes we need to have the result of multiple network requests come back before we can do the thing. And that's a little tricky to deal with in, sort of wrapping your head around, like, how do I structure this code? Do I call the first network request, and then when that comes back, then I call the second one? If not, how do I do something when both of them finish? It's not immediately obvious. And we're gonna do that. We're gonna use a tool called dispatch groups. I've got a tab for that here. And so I'll show you how to do it. So let's look at the API documentation first. This is gonna start very similarly. So in this case, we're getting like products from product catalog. And in this case, we want to show a product detail screen. And to do that, we actually have to query 2 different endpoints. We have to ask for /product/ and then we'll give it a product ID. And we also want to call /inventory and give that a product ID. So this one is going to give us like the name and description, and we're going to ignore the image for now. Maybe we'll get to that if we have time. And then the inventory will just tell us how many of those products we have in stock. And to show a full product listing, I'm going to need to request both of these, and I can't load the page until I've got both of them. Now, you could maybe make the case that the design decision you want to make here is load this stuff as soon as you get it, put a little spinner and load the stock when you load that. Like, that's fine. You can do that. What we want to do right now is pretend that these are coming from a better designed API that has just one endpoint. And so we're going to pretend to the user like, hey, we're loading. Cool, we've got everything. Let's show it. I think that's a really common use case. So back to the app, we have our models here for our product and our inventory. Those just match the JSON that we just saw. And our API client has two stubbed out methods for exactly the same idea. So we're just saying, hey, get me a product with this ID, and I will call you back with the product. And get me the inventory for the product with this ID, and I will call you back when I get the inventory. So we're going to write those up fairly quickly. It's going to be pretty similar to what we did before, a little bit more complex to construct the URL. So just as a refresher, this one is /product/ and then the actual product ID that we want. Although in the testing server, I think we just always return the same, but that's fine.
Yeah, it will always return whatever product ID you pass in.
Okay, great. So a little bit of hand waving here, but that's okay. It's not a workshop about API design, but please don't design your APIs like this. Unless you have to, there's reasons. So we're gonna make our URL, so the local super URL, and then we're gonna append the path component product, and then we're gonna append another path component, which is the ID, and it's already a string, so we'll just tack that on the end there. And then I'm actually just gonna copy this because it's basically the same. So we're just gonna request the URL, get back some stuff. We're gonna decode a product instead of a quote, and I believe that's actually the only change. If you're thinking like a programmer, you might be thinking, hey, if that's the only change, maybe we could coalesce these methods into something a little more shared. Yep, you totally could. This is not a workshop about that either, but feel free to go to town on the example project if you want. And then totally the same thing down here with the only two changes, being that this is inventory instead of product, and this is decoding an inventory. Okay, so we have our two methods. This one's going to get us a product, this one's going to get us an inventory, and they're going to both go off and do their own thing, and they're going to come back asynchronously at some time in some order. It's not defined. We can't really rely on like, you'll see this sometimes like, oh, I know this endpoint's faster and this one's slower, so I'm going to just rely on that order. You really shouldn't rely on that order. You should make the ordering explicit, or dependency on ordering. That's what we're going to do. We're going to say we definitely don't want to handle the result until both of them have definitely come back. So dispatch groups view controller. So this one, we're going to be loading this product detail, and I'll show you the storyboard, show you where we're heading. So we just have title, number in stock, and then a description, and we have our loading spinner. So fairly similar setup. And I'm going to get the cheat sheet up on the other screen that you can't see. Okay, so when our view loads, I set up, I guess I did the initial setup here this time, where I would just set set it to a not like an empty view. So what are we going to do? Let's do our little number things again. So put UI in loading state. So then we're going to request product, request the inventory, and then when they're done, somehow update UI once both are done. And I'm going to be a little less explicit about the finicky details, but we'll get the code in there eventually. So let's get rid of some busy work at the beginning. So again, we want to disable the button, and then I'm just going to copy in some code for just setting all the labels and things to empty. And this is important because yes, they're empty now, but after we load the product, they'll be full. And if we click load product again, we'll want them to empty out while we wait for the next product to load in. So I'm just going to always clear those out and start the spinner animating. And I'm going to start off with the sort of naive, all right, let's just start requesting things, and we'll see where we start to run into trouble. So I'm going to say the product ID we want to request is 123, and API client get, hopefully it would be like the product the user clicked on or something. So with ID, product ID, and the completion, call this result. Okay, so we have, at some point we'll get back product result. And then at some other point, I'm gonna get the inventory with also product ID and same completion and print inventory. Okay, but here's the problem. If this one comes back first, its completion will get called, and maybe I go update the UI, but then I don't know when this one has come back. And if this one calls back first, I don't know when this one's going to come back. Let's see what happens when I run this. We should get some printouts, and I don't know what order they're going to be in. Okay, we got our inventory first. It's this one, and then our product second, even though we requested product first and inventory second. Now, the actual reason is because in the server, in product controller, I put a sleep of 2, and in inventory controller, I put a sleep of 1. And so they're like, the server is going to send those back in a deterministic order. But just for fun, we could do like, sleep for some range of like from 0 to 3 seconds. One of, a random element in 0 to 3. So now they really are going to come back in a non-deterministic order. So now if I call this again, oh, right, I haven't updated the UI to actually, go back into normal state again, not quotes, sorry, dispatch groups. So the first one, product came back and then inventory. And if I run it again, I keep clicking that, that's gonna happen a lot. Product, but then inventory with later, you get the idea. It's the server is just gonna randomize it each time. So we wanna make sure our code is definitely gonna work no matter what order things come back in. So the way to solve this, or my favorite way to solve this, I guess there are a couple, but my favorite way to solve this is something called dispatch groups. So a dispatch group is basically an object that does the thing that we want, which is tell it when I'm about to start an asynchronous thing and tell it when I've finished an asynchronous thing, and then do something once all the things have finished. So the way it works is each time you're about to start something, you say group.enter. And each time you finish something, you say group.leave. So we're going to enter this one, group.leave this one. So pay careful attention to what's happening here. I'm calling enter basically twice immediately because this line of code runs, and then this line runs, and then this line runs, and the networking thing hasn't even started up yet. So we're not leaving the group yet. So we've entered the group twice. And then eventually when both of these come back, we leave the group. And the last piece of the puzzle is we can say group.notify, and notify lets us pick which dispatch queue to notify and what to do when we notify. So I'm going to say the main queue, and what do we want to do? We want to update the UI once both are done. So those are the main pieces of dispatch group. You make your group, you enter it as many times as you are about to do asynchronous things, and you leave it as many times as your asynchronous things finish. So it's a pretty tidy API. The one slightly annoying thing is, well, we'll see if we can arrive at the slightly annoying thing. So I'm gonna do my same result handling. So success, let product do something, and failure, let error do something. But what do I do with this product? Where do I put it? I can't just update the UI because I'm waiting. I need to somehow get this product into here. And probably the least annoying way to do that, and all the ways are pretty annoying, but probably the least annoying way is to just make some little placeholder variables here. So like, say these are variables to store the stuff that we fetched. So we'll make an optional product inventory and an optional error. And I don't love this because these are all optional, and at the end we're going to have to switch over or check them and figure out whether they're set correctly. You could do some cute things with result types maybe, so that's something to think about, but they have to be optional, unfortunately, because if I make this non-optional, I don't have an initial value to set it to. We could get down to here and it would never have been set, and Swift won't let us do that. So I need to actually set it to nil, and then we'll set the value in here. So if I got a product, there, I'm going to call this fetched product because we don't want it to have the same name. So product equals fetched product, and this will be product, get product error. So the error is get product error. If we get 2 errors back at the end, this error will just be whichever one we got last, which is probably fine, but if you care about that, you can make this like an array of errors and get really fancy with like, storing all your errors and everything. It's usually not worth it though. So we're gonna repeat the same pattern down here. So fetched inventory, get inventory error.
Yeah, what's the refactor hotkey you just used?
Oh, yeah. So Command Control E, and if you can't remember that, you can find it under somewhere. Oh, editor, edit all in scope. And it's nice because it's not a full refactor. I could do refactor rename and it would do the whole accordion thing and it would go search across my whole project. But if I know it's local, it's like in scope basically means in file. Command Control E will let me edit all of those at once, which is
today I learned.
Yeah, it's a good one. It used to have this little like weird square triangle pop-up thing. I don't know what happened to that. I think that went away in Xcode 10 or 11. Okay, so we have set things into these variables, and now at the end here, I know I'm on the main queue, so I don't have to worry about that like I did last time. And I can do my cleanup, so like spinner stop animating and re-enable the button. And then I gotta go and look in my product inventory and error, and based on what's set and what's not set, figure out what happened. Little bit sort of archaeology. So if let product equals product and let inventory equals inventory, so unwrap both of those, and if I have them, then we're gonna for a update UI with success, and then else if let error equals error, or B update UI with failure. In my sample code, I didn't do a like else. You probably should, but like if you didn't get things back and you didn't get an error, man, I don't even know what's going on. In your app, you might have a better idea of what would have happened in that case, but it's worth thinking about. Otherwise, your UI will just hang out forever. Not actually, sorry, it won't hang out forever. I don't need this else because we have turned off the spinner and we've set the button back, so you could try it again. Anyway, that was a digression. Let's update the UI for success, and then we'll do our fun little error trick and do the error one and see how it's going. So I got back my things, so I'm going to do title label text equals product.name and stock label text equals oh yeah, so number of things in stock, and the description label is going to be the product's description, and we'll do our nice little animate trick again. To set the alpha back to 1 because I set it to 0 before, so we'll animate in. And that should be all we need to do let's see if it works. So load product, and we get a product. We get our title, we get the, so the title and description came from the product endpoint, and the in stock came from the inventory endpoint, and they didn't call back, or the whole thing didn't call back until they had both finished. And click it again, we only have one product on the testing server, so it'll be the same one. You can see that it works multiple times. I think it gives us a random stock each time, so we can actually see that it's reloading, unless it gives us the same random number twice.
Zev, could
cool.
you toss a few breakpoints around to sort of highlight where the concurrency is coming in?
Great idea. So also good sort of little preview if you haven't played with breakpoints before. So I'm just going to throw one like here, and then some inside the various groups, and I'll do one here as well. And then inside the notify, and I'll put one last one. You can kind of get the shape of it. Yeah, somebody noticed your hand sanitizer description.
Thank you for noticing. I was having some fun while I was building the server.
It's called when both group.enter. So group.notify is called when both group.enter if it's successfully called group.leave. Yes. Yeah, so they're basically in pairs. So for every enter, you have to call leave. There's probably a documentation thing somewhere that says like, please call these, in pairs. And if you don't, you've made a horrible mistake.
Yeah, I've definitely spent some time tracking down that error where we've entered more than we've left, and I've also had it where we left more than we entered. It's been fun.
Yeah, it's annoying. It's worth being really careful with your code to make sure that those things are close to each other and it's easy to see that you've done them correctly. Like I don't think I would put this above the switch, because then you would leave the group and this notify would potentially happen before this stuff even happened. I'm not sure if it exactly would, but one nice way to put it up here so it's visually close, but have it run at the end, is to put it in a defer, which is a little used Swift thing that basically just says, do this at the end of this scope. I don't know if I love that. I always feel like I have to think a little harder when I see a defer to know if it's actually doing the right thing. Someone says, I'm new to Swift, and would you mind explaining why you put this button action in an extension? Oh, yes. I just like to use extensions to break up logical groups of things like view controllers, just because otherwise the view controllers get big. So I like to label, I labeled this one actions. I forget if I did it in the other view controller, but this one's a bit bigger. So I know that everything in here is related to button actions. It's just a style thing.
Yeah, it's definitely.
I talked about it.
Go ahead.
Mm-hmm. I'll link to a blog post where I talked about it a little bit.
It's definitely a style choice. It's not a requirement of the language, but you'll see a lot of people do that if they have a view controller that has a table view or a collection view. They'll put those into extensions just sort of to sneak it away. Like Zev said, these files can get really big, and so you start finding your own tricks or common tricks for making code a little bit more readable and manageable. And maybe he doesn't like how big this file gets. He can move that entire extension out into its own file, which comes with its own drawbacks, but you sort of find what works for you.
Yeah, when I was first learning Swift, when was this post? In 2016, there were just a couple things that kind of surprised me coming from Objective-C, and that may not be the background that folks in the chat have, but still, there are just some things that are like, oh, okay, this is a Swifty way to do things that I didn't really realize until talking to people who knew more Swift than I did. Okay, so we are at the point where we wanted to run this, and we're looking at breakpoints. So first things first, we hit our button, and after all our setup and stuff, this is the first breakpoint that we hit. And for those not familiar with breakpoints, this button here, step over, the little arrow jumping over thing, will just jump to the next line. So if I click that, it just goes to the next line. And the one that looks like an eject button that's sideways is continue, basically resume the program until the next breakpoint is hit. So that's the one I'm going to click, continue program. And we jump right to the next group enter, because remember, anything in between is squirreled away somewhere to eventually be called when the network returns. So we haven't even done our network request probably. So we're entering the next group, and I'm going to hit the next button again. And we've gotten all the way down to this after notify because the notify also squirreled away this code to be run later. So nothing has actually happened yet. All we've done is set up all the groups and network things to run once the network things come back. So I'm going to hit continue. And by this point, enough time has passed that our get product came back. So that one happened. That happened to happen first this time. And I'm going to hit continue again. And did it hit again? The debugger sometimes lies to you and is just in general very terrible and confusing. So if it does things like it looks like it hit the same line twice, I'm guessing like it just sort of does that sometimes is my main explanation there.
Yeah, I see that all the time.
Yeah. I guess it's kind of hard, especially with asynchronous things, to know like, okay, but actually where are we right now and what line of code actually am I on right now? Also because the order that things are compiled in doesn't always exactly equal the order of your lines of code. Like sometimes the sort of logical steps will be shuffled around in your code because the compiler says it's better that way. It doesn't change the logic. It just means two things that don't otherwise matter might happen in a different order. Okay. Anyway, we're in inventory, and I'll continue. And again, it did the weird double throw on that line, and that's fine. And now finally, we're in the notify for finishing out. And I hit continue, and now everything loads. That was a great idea. So clear all those out. Oh, fun tip, if you forget and you have a bunch of breakpoints, you can go to the breakpoint navigator and select your breakpoints and hit the delete key. They'll go away. You don't have to drag them out one by one.
You can also drag out the entire controller.
Yeah, nice. Yeah, if you want to do them all, everything that's in one file, you can click on this whole thing. Oh, can you just drag it out? Yeah, you get the little X. And does the X show up on the
Yep, it's showing up.
Sweet. So there. Okay, so we just need to do our error state. I'm just going to cop out and just stop the server. So the error we'll get is just server not found, which is fine. And I'm going to do the same thing I did last time, just a simple alert. In fact, I'm just going to copy and paste from my code on my other screen. So nothing too fancy. We're printing out the error for logging. We're making an alert, making the message the error's localized description, and presenting the alert. So let's see if that works. So load, I get error, could not connect to the server. I can do it again, I get the error again. I run the server. And now I can load quotes. So again, it feels like that was a lot in a short amount of time. But I feel like with those two things covered, that's like, we're at sort of like 98, 99% of what sort of queuing stuff you're doing. And like, we haven't really even talked that much about what queues are or how to use them in more advanced cases. We're going to talk a little bit about that in the third example. But like, if this is as far as you get, and this is as far as you're comfortable with, that's pretty much fine for most things, because most things in iOS are go out to somewhere, get something, and let me know when you got it. Whether that's the network or a local database or files on disk, a lot of those things happen asynchronously with these sort of closure-based things. And it's really just all about knowing when to put things onto the main queue. That purple warning that I got earlier when I had forgotten to put something on the main queue, that actually comes from, I should do that without the keyboard shortcut. If you go into your scheme here and edit the scheme, under diagnostics, the main thread checker is turned on by default. And that's the thing that caused the purple line to show up when I did a UI thing not on the main thread. So that's probably turned on in your project. It's on by default. Oh, cool. They even have this little arrow that will take you over to the breakpoint navigator and create a main thread checker runtime issue breakpoint. So it will actually stop you. I think somehow it managed to magically do that. I don't think you need the breakpoint, but it's there if you need it. Cool. Yeah. So the last example I wanted to talk about is maybe getting on towards a little more sort of advanced usage. And we were actually struggling to figure out like, what is a good example here? The idea is another really common use of queuing is you have some expensive work to do. And if you just it's usually a good idea to just build things on the main thread as simply as possible and see what happens, and then only start dealing with queuing and concurrency. Um, uh, yes, great question. The thing in the chat, that's what we're going to talk about. Yeah, so in this example, I'm actually going to build it on the main queue first. Let's get rid of this. You haven't seen that yet. I'm going to do this in the main queue, show how it's slow, and then yes, we will have to explicitly put it on a background queue to make it faster. And Matt and I were talking about trying to figure out like what's a real world example of this. And like for real, in almost 6 years of working at an agency, doing a lot of different apps for a lot of different clients, I ran into a case where I actually had to do this like one time, maybe 2 times, where we had a giant data dump coming from a server, and then we had to process a bunch of data into a database when it came back from the server, and do that without blocking the UI. And like that was it. It took really extreme conditions to even run into a case like this in a real app. So we kind of had to contrive some stuff to make a useful example. Our first example idea was download a bunch of giant images in the background and resize them to thumbnails, but it was literally too fast. Like I couldn't make it slow enough that you would notice it, which is great. Like I'm glad that this is the future we live in. Well, not all of it, but that part of it. But it was not useful as a demo. So the demo is completely contrived. And what we're going to be doing is some arbitrary expensive math function. What I'm actually doing is I'm taking some number and I'm taking the sign of it 1,000,000 times. So it's like sign of sign of sign of sign of the input of this function. That wasn't real syntax. I was just illustrating. Anyway, it's just this whatever math function. You can put anything in here. I wish I had a better example, but this is what we got. So let us run the app, and we'll see where we're starting out with this third example. So this is the parallel processing tab here. And we have a collection view that just has a bunch of placeholder math things, and it might look like a photo gallery. That's because, like I said, this was originally going to be a photo example. But we're gonna call our expensive math function for item 0 and item 1 and item 2 and item 3, etc. And when we get the answers, we're going to put those in the cells just as little text labels. So I'm going to do this the slow way first, the main thread way, which is, again, how you should build things until you know for a fact that they're too slow. So like, this is what I would do if I were building this for real. So let's see. So when we tap the math button, let's do our steps again. I'm going to set all cells to loading state. I've made this little cell subclass that just has a state that you can set it to, so it has a spinner. And then for all indices, we're going to do expensive math, and then update UI with results. So set all cells to loading state. Some of this should be repeat by now, except it's a little different because of the it's a bunch of cells instead of just one UI. So I'm going to oh, I didn't even do this in my sample code, but we should set the sender dot is enabled equals false, just to sort of hammer that home. And then, actually, sorry, for dumb reasons, I'm going to not do that, just because I don't have a convenient way to undo it in this sample code. Please do it in your real apps. Okay, so I'm going to set my items. I just have an array that's backing this collection view. Please feel free to stop me if any of this is confusing. I'm kind of glossing over some of this because it is a little bit more of a complex like setup. Like it's not interesting complex, it's just there's a little more code here. So I'm going to use this convenience initializer for array. So I'm going to say I want to repeat my loading state, the number of items I had. Okay, I guess I'll explain this. So my item is this little enum that can be either empty or loading, which means spinner, or loaded, which will show the input that I gave it and the output from the function. So this is just like, okay, I'm done. Show me the end result. So they all start out empty. There's 150 of them. And then I'm going to replace that array with the loading state. And I'm going to ask the collection view to reload itself so that we can see that result. So let me just run that and make sure we can get into our loading state. Do math. Hey, now we have a bunch of spinners. So each cell is going to spin, and then as the results come in, they're going to replace with the result. So then for all indices, so that's a simple for loop for index in self.items.indices, and I'm using indices instead of just like for in self.items because I don't just want the item, I want what number it is, like item 0, item 1, item 2, because I'm going to use that number as the input for my pretend math function. So do expensive math. So let result equals self.do expensive math to my index. So that's just going to take the sign of index 0 a million times and then the sign of index 1 a million times. And then I'm going to let my new item be an item in the loaded state with the input as the index. So like, hey, what was the value you gave me to get this output value? Let me know if that's confusing. I think I explained it okay, but if somebody doesn't understand, I'm happy to explain again or figure out some other way to answer that. And then we need to update the UI. So I have this little utility function that I'll call and then I'll implement. So we're just going to say update the item, the one I just made, at the index. And so we need a function that will do that, which is basically, I have a new item, I want to stick it in my array and ask the collection view to just reload the cell at that index. So we don't have to constantly reload the whole collection view each time one thing changes. So that's going to be my items array at that index will be set to the new item, and ask the collection view to please reload items at, okay, this one's an array of index paths. I'm just going to give it one index path. And I don't have, I only have one section, so I'm not going to worry about the section. It's just always section 0, but I'm going to do it at the index of that item. So quick reiterate, we set all the cells into loading, and then for each one of those cells, or for each item, we're going to do some math. This is going to take a long time, and then make a new item out of the result and update the collection view at that result, at that index. So I'm going to run it and let's see what happens.
There's a question in chat. Why do you have input and output on .loaded?
Oh, so that's just for the output style that I wanted in my view. I wanted it, and you'll see it when it eventually loads, which it won't because it's too slow. It's going to be like 0 colon and then the result, 1 colon and then the result. So I needed to know which index it was so I could put that number. You wouldn't need that if you didn't want to show the number there. It's basically just model data is the way you can think of it. I just needed 2 numbers there. Let me know if that didn't answer your question. So, okay, my fan has started going on my laptop. Nothing has happened here. I can't drag in the UI. Obviously, this is not a great situation. If we go over into the debug navigator, we can see the CPU is pegged at 100%, which is not ideal. I mean, sometimes it has to be if you're actually doing expensive work, but you can see in the graph here that thread 1 is pegged at 100%, and thread 1 is supposed to be the main thread. Thread 1 has to stay responsive so that I can actually, you know, do stuff. And it's not right now. I've totally saturated thread 1. Let's see if, I think if I cut this down to like 10,000, we can at least see it work. But obviously this is not tenable. We're gonna have to figure out a better way to do this. So if I click do math now, okay. Now they all came in. I think 100,000 maybe will be a more realistic or more reasonable compromise between seeing that it works, but seeing that it's slow. So do math, we wait. You can see our CPU at 99% over here. It's good to keep an eye on this graph. But hopefully within, yeah, okay, about 10 seconds, it loads in. So this is our final result, just so you can see what it's supposed to look like. So we just say like, oops, f of 0 is 0, f of 1 is this number, f of 2 is this number, and so you can see those results. So something's got to change, right? I don't have anything to do in this app while I'm waiting, but you could imagine an app where while you're waiting for something to process, you still want to be able to scroll and look at stuff, and generally you want to keep your app responsive. So let's see. One way that we were doing things, and often you'll see people say, oh, if something freezes your UI, just stick it on, do a dispatch async main queue. And by the way, one other thing we should notice is when I click do math, we don't get our loading state, right? We asked the thing to go into loading state, and we asked the collection view to reload data. But before it got a chance to start doing that, we immediately pegged the main thread. So we want to give it a chance to actually get into its loading state. And we want to do this stuff in the background. So the way I'm going to do this is I'm going to use dispatch queues. We've been using dispatch queues all along, but I'm going to use them in a bit of a new way, which is instead of using the main queue, I'm going to make my own queue. And actually, I think I might want to do a quick illustration just so you can see, just kind of visualize, because a lot of this stuff is hard to sort of conceptualize without just seeing a simple diagram of it. So let me, haven't tested this. This is the curveball, but should work.
Yeah, everything's looking good so far.
Sweet. So I've got my iPad here. Just gonna make a quick sketch. So our problem right now is we have the main queue. Let me just make that a bit thicker. Okay, so we have our main queue. And normally, you'll do a thing, and then a bunch of time passes, you'll do another thing, you'll do another thing, but the main queue stays responsive. But the problem right now is that we're doing one giant thing that is taking up time on the main queue, and any other, the touch comes in, and it can't run on the main queue because the main queue is busy. And so we want to have that not happen. So, so what we're going to do is we're going to make another queue, and this is going to be our math queue. Boy, there's a lot of vowels in that word. And so in the main queue, we're going to push our button. So button press. And that event is going to kick off some work on the math queue. The math queue is going to get real busy doing a whole bunch of stuff, but the main queue will keep going. If I have, I scroll, or I update a spinner, those can still happen because some other CPU core is off running this other queue. And then when this other queue is done, it can send back the result to the main queue. So let's try that. That will be sort of step one. We're going to sort of move this over to be better in stages. So I'm going to make a queue, and dispatch queue you make just like any other object. So let's see, what did I call this in my sample code? Yeah, so math queue. So I'm going to make a dispatch queue, and you can give it a couple different properties. It's always a good idea to give it a label. I forget if it's required, but I definitely would, because it will show up in the debugger as that label. It makes it easier to figure out what you're looking at, which we will definitely do. We'll ignore QoS probably for this talk, although if people have specific questions, I think I saw one in the chat the other day. We can chat about it a bit. And then I'm going to leave attributes empty for a second, but we'll talk about that later. And we'll ignore these other properties. So we've made a dispatch queue. It's called math queue, so we'll be able to find it. No attributes for now. And your queue has to be owned by something so it stays alive, just like most other objects. So our view controller is going to own it. And now we're going to use it. So I've put my thing into, I've reloaded the data, and now I'm going to do all this other work on this math queue. So I'm going to say math queue let me look at my sample code, see how I did this. Async all of this work. And we should talk about async versus sync in a second, but let me get this written first. And then after I've done all my indexing and updating, oh, okay, I might have to skip to the end here because I don't have a good way to write the interim step, which is I don't actually want to do all of this work on the background queue. I want to do it and update the UI as each one finishes. And the only easy way to do it all first, I was going to demo it by like saying, look, we do all this work, but nothing updates until the end. But I would have to set up a dispatch group and do a whole bunch of shenanigans for that. I'm going to skip right to the end, which is saying I'm actually going to do each of these pieces of work on the math queue. So I moved the async inside the loop. So for each one of these things, please go off to this queue and do some work. And then when you're done, please take the new item that you made and please update on the main queue. And I will update my diagram so you can see what the heck I'm talking about. So yeah, let me do that now actually. So diagram. So this is going to change slightly. What we're going to say is, let's see, clear that. So I've still got my main queue. And then I'm going to ask it, I actually need my other queue. So this is my math queue. And then I'm going to ask it to do math, or do a math, do one math, please. And then that's going to be working on that. And meanwhile, I'm going to ask it, okay, but please do another math, and please do another one and another one. And the cool thing about queues is I can ask it to do 150 of these, and they'll all just happily pile up on this queue. Really, this illustration is not super accurate. What I should instead say is I'm going to ask it to do these all, and they all happen instantly. As far as the main queue is concerned, there's this one little blip of activity where it enqueues all these things, and then the main queue is happy to just keep on doing its work. Meanwhile, my math queue gets to work and it does the first one, then it does the second one, then it does the third one, then it does the fourth one, and it will eventually get to all of them. And then after each one of those is done, it's going to say, okay, I'm done, and call back. And the main queue will just sort of fit those in wherever it has room. Maybe this one is a scroll event, and maybe this one is some other update. And as these things happen, this dispatch queue main async from off on the queue. So each of these is an async to main. So each of these goes back to the main queue when they're done. At least that's the theory. Let's see what happens. Cool. So now, if I can get ahead of it here, we see them loading in one at a time as they finish. So that's pretty cool. Keeping the main queue happy, says Blue Star Theory. Yes. Yeah, you want to keep the main queue happy. So that's cool. But there's another neat thing we can do, which is right now we've only been talking about what's called serial queues. And so this queue was serial, and serial means it does one thing at a time. We can actually make something called a concurrent queue, and a concurrent queue can do more than one thing at once. The main queue is always serial.
There's a great question in chat. Are the terms thread and queue always interchangeable?
That is a fantastic question. They're not. Thread is an older concept, and it's a little sort of, you can think of it as being closer to the metal in that slang term. That means like, more bare bones, more old school, more directly on the CPU. I think something like each CPU can only run one thread at a time ish. I think with Intel's hyper-threading, you can kind of work around that, but basically each CPU can only run one thread at a time. So if you have a single core computer and you're trying to do multiple threads, the CPU basically has to stop one thread and run the other thread and then stop that one and go back to the first one, and that can cause a lot of slowdowns. But then if you have multiple CPU cores, it can happily go and run as many threads as you have CPU cores. Queues are a higher level concept that Apple introduced a while ago now as part of this library called libdispatch, which is what we're doing. All of this stuff. Eventually, this will become a little nicer because Swift will eventually get built-in support for concurrency. Currently, Swift doesn't actually have any concurrency built into the language. Everything that we've been talking about is part of a library called Dispatch that is built by Apple. It's built into all the Apple, fancy shiny piece of glass things. And it's a library that lets you do these sort of concurrency ideas. And it has some of these higher level abstractions like serial and concurrent queues. And the idea behind queues is you describe the queues. The queues are responsible for going and making threads as needed and destroying threads as needed. I remember some old demos back from when Dispatch stuff was first coming out, where they showed an example of like the mail app, which is super duper threaded because it's always doing stuff in the background, right? It's like fetching mail and updating databases and indexing and things. And they showed an example. You can actually pull it up in Activity Monitor. You can see in Activity Monitor, you can see the number of threads that any particular process has running. So like my kernel task is 329 threads right now, and Zoom somehow has 57 threads. I don't know what it's doing. But Adobe, of course, biggest vendor here. But so you can see how many threads things have. And the neat thing they demoed with queues was that when you did a big operation in an app like Mail, the number of threads would ramp up as it needed them, but then it would ramp back down when it was done, so it wasn't holding on to a bunch of threads. And they were claiming that that's a lot harder to program by hand with threads. But if you use queues, it kind of sort of takes care of it for you. Asterisk, asterisk. There's always asterisks. So we're going to be making just one more little pedantic point on that. The main thread and main queue, you'll often hear them used interchangeably. Remember that purple warning from before said you have to do UI updates on the main thread, and that's true. There's a weird little wrinkle to this, though, which is, if I can get a text editor up, I just want to write it out so it's totally clear. So main queue always runs on main thread. There's also like a 50-50 chance I'll get this wrong. We'll get it backwards. You can Google it to make sure I'm right. Main queue always runs the main thread. Main thread is not always running the main queue. There are cases, I don't really understand when or why they would occur, but there are times when the main thread's hanging out and it's like, oh, I got, eons and eons until the next 60th of a second refresh of the display. I got nothing else going on. Let me run some work from another queue. So occasionally, very occasionally in specific circumstances, you'll like pause your app and notice that you have work on the main thread, like thread 1. Threads are indexed from 1 for some reason. That is not on the main queue, which is weird, but worth knowing because a lot of people just consider that these are synonymous, and they mostly are, but sometimes not. So we're going to make a concurrent queue. And a concurrent queue, the way this works is when my work gets dispatched over here. Okay, so we're going to, send a bunch of requests to do some work. And the concurrent queue will go, all right, I'm going to start this one, and it's going to take some time. And I've got a little capacity. I'll figure out some threads. I'll figure out how many CPU cores you've got, whatever I need to do. So maybe I'll start another one and see how long that takes. And like I'm drawing these all the same length, but here, like some of these could be longer and some could be shorter. But maybe I'll start 4, and then this one finished, cool. So I can start another one, and then this one, and it will just sort of manage running these little items of work. And so if you have a problem that you're solving that can be broken down into small pieces, a good example would be like if you're running some filter on an image and you can break it down into little chunks of image and run that filter on all the chunks, you can put that on a concurrent queue and take full advantage of all your CPU cores, which is like really cool when you find a problem where you can take that kind of advantage. And then when each one of those finishes, they are sending back, okay, this diagram's getting useless, but they're all sending back to the main queue when they finish, and the main queue will slot them in. So that's what we're going to do. Real quick, before I do that, I just remembered one little demo I want to do, which is just to sort of get a sense of what the machine is doing at any given time. Two things. I want to look at the CPU graph again when we do math. Remember, before the main thread was just spiked and then stuck at at full usage and nothing else was happening. But now that I've gone off the main thread, I'm going to do math, and we'll see that the main thread's doing. Wait, what happened? Oh, this might be one of those cases where the work is actually happening on the main thread. Oh, it may have just finished. You know what? Now that things are in the background, I'm going to kick it back up to 1 million iterations so that we can actually like slow it down enough to actually see what's going on. That might be a little more obvious now what's happening. Okay, wait for the main thread to quiet down. All right, do math. There we go. So now we can see the main thread's not doing much of anything. If you looked closely, you'd probably see little spikes when the UI updates, but you can see thread 5 is the one that's doing all the work. And I can click the little pause button at the bottom in the debug toolbar, and that will pause and show us what each thread in our app is doing. And we can see the main thread is hanging out, I guess not doing much, but here's our math queue. And we can see what it's doing. And oh, look, it's in the middle of our math loop thing. And it even shows that it's doing that because it was enqueued from this here. When you dispatch stuff async, it keeps a record of like you hopped from thread 1 to thread 5, which is like super useful as a debugging tool. That gives you a good sense, and you can just click that button anytime you want and see what every thread in your app is doing. Like there's this event fetch thread, which is probably doing something about like checking in with the touch sensor on the iPad on the iPhone screen to see if stuff's going on, and thread 8, which is not doing anything. And like depending on what your app's doing, you'll see more or fewer threads here. Networking will show up in its own thread. So really cool to be able to just stop the app anytime you want and see what's going on in all the threads. Okay, so this is still serial, and we can see these things happening one at a time. And at 1 million work items, you can see each one takes about a second to do, which is pretty cool that it's cranking through 1 million sign operations every second. That's nifty. So we're just going to make one change here. We're going to change this dispatch queue from, with no attributes, it's a serial queue by default, but I'm just going to put in the concurrent attribute. And that should be the only change I have to make. Do math. Whole block of 8 all came back at once. Let's see what the CPU is doing. Oh, cool. Instead of 100% CPU, now I'm using 1300% CPU. So that's neat. And if I click in here, you can see a whole bunch of threads. You see it spun up. I only had like 5 threads before. Now it's spun up 22 threads, and they're all cranking as hard as they can in the background. It's already done because it did them all in parallel, which is like pretty cool. I'm on an 8-core laptop right now, so I probably have 16 threads available because of hyperthreading, and you can see that in Activity Monitor if we bring up this view, like woo. So if I do that again, you'll see my actual laptop cores spike. And it's worth noting that it's basically useless to do performance testing in the simulator. Okay, well, this isn't updating fast enough to be of any use. Oh, there we go. See, they all spiked for a second. It's not worth doing performance testing in the simulator most of the time because the simulator is basically just running on your computer. So like this looks like an iPhone, but it's actually an Intel compiled Mac app. And if your computer has 16 threads, it'll be like, all right, I'll use those 16 threads. So for doing any kind of real world performance testing, you've got to run on device. You can still get a little bit of a sense of like, is this approach faster than that approach by trying it on the simulator? But even then, there's a different amount of RAM, there's different number of cores, it's just different, and performance testing is not all that valuable in the simulator. So anyway, that was a concurrent queue, and that was like pretty neat to just magically instantly take advantage of all those cores. Oh, I guess one more thing would be pause it and let's see what the threads actually look like. So do math, wait for it to get going a little bit, click the pause button. Cool, I got a whole bunch of threads. They're all running my math queue. So the queue is like, hey, I need to do a bunch of things at once. Give me a bunch of threads. And I can flip any of them open and see exactly where they are. I can click here. If I had, like, I can see this thread 3, which is currently running my math queue, is working on input 22, like the number 22 was passed in, and thread 12 is working on input 29. So I can even see the local stack frame variables for each input, which is pretty useful for debugging. I still wish some of the concurrency debugging tools were better, but like it's pretty neat to be able to pause anywhere and just jump around and see what all the threads are doing. So it's useful if you need to do that sort of thing. I said that was a lot after the other two, but really that was a lot on that one. I do want to quickly touch on sync versus async, but other than that, feel free to throw any questions about any of the concurrency stuff in the chat. So one quick thing on sync versus async. Remember how back in our dispatch groups example, we set those breakpoints and we kind of jumped all around, right? Because like we did our inventory thing and then it just enqueued that and we jumped to the next one, and then later when that came back, it ran in here. That's because these things happen asynchronously. Sometimes you will do some work that is synchronous, and what that means is it won't just enqueue that work on the queue and go on to the next thing. It will sit there and wait until that work finishes before going on to the next line.
So that's a good segue to a question of when we're using a serial queue, will it always return in order you sent the requests in?
Yes, on a serial queue, it will operate on work items on the queue in the order that they were submitted. And you'll also get some stuff like I was doing some stuff with queue suspend and resume recently. So you can take any queue and just say like, hey, please stop. I think it's a little harder with dispatch queues, but with there's a thing called operation queues, which are a little sort of higher level version of queuing, and you can just like stop a queue and it will keep running anything that's already on the queue, but anything new that you add to the queue after you suspend it will be sort of blocked until the queue finishes.
And is there a downside to concurrency and using all the cores that are available?
Yeah, it depends what you're working on. So, well, first of all, some tasks just aren't parallelizable. And if you're not careful, if you think your task is parallelizable, but then you do a bunch of things and they all sort of come back in some random order, that could potentially be harmful. So you want to make sure that you understand that the task you're solving, it makes sense to split it up into a bunch of things that could come back in any order. It also is going to tax your CPU to the max. So if you're in a game and you're just doing some sort of like you're playing a game, you're wanting to maintain your 60 or 120 frames per second, the game needs all the attention, it doesn't make sense to go and rotate your logs or submit some analytics on some super fast concurrent queue. You want to kind of chill with that kind of thing and really put your important work there.
And that's where the QoS or quality of service thing kind of comes in, which you quickly touched upon.
Yeah, quality of service. So there's a WWDC talk that you should go and watch if you're curious about quality of service. I was actually just today reading some advice from someone about quality of service. The idea is, and maybe you saw it when I was constructing the queue, there was, I thought it was a parameter.
I think it's after attributes.
After attributes.
That's QoS. Maybe it's after label.
Yeah. So quality of service, you can basically say like, what are the QoS class? Yeah, so there's a few different classes of quality of service, and you can say like, basically, here's how important the work on this queue is. And then if this computer has to decide between, I'm going to work on this queue or this other queue, it'll go, oh, user interactive. Well, that means the user is like actively moving their finger right now, and I'd better run this work now so I can keep up with their tracking. But like utility and background, I can squeeze it in when the user's not touching the screen. And this stuff happens like by the microsecond. Like literally, CPUs will ramp up their clock speed and ramp it down in between keystrokes as you're typing. So there's some pretty advanced scheduling going on, and some of this QoS stuff is related to that. The latest advice I heard is that you basically almost never want to specify the QoS yourself. Instead, you want to go get the system actually provides a couple of queues, global queues. I made my own queue here, but you can go like, so we did dispatch queue.main. There's also dispatch queue dot. I don't use these that often, so I'm not going to remember where to find. Oh yeah, so there's global. Oh yeah, this is what it is. So I can get a global queue with one of those quality of service classes, and it will just give me, it's like some queue that already exists somewhere in the system, and it will go and get it for you. Like, hey, give me the background queue, give me the user initiated queue. And I think that's more likely what you want to use rather than specifying it yourself. The dangers there, I believe, are related to priority inversion, which I have a very rudimentary understanding of, where like if you have some queues set up and like this one's user interactive, but it's sending its events to another queue that's like a background queue, it's going to make the other queue go faster, which might be what you want, but might like rush a bunch of stuff you didn't care about. And it sounds very complicated. I don't understand it very well. You should definitely go and find, actually I will post WDC quality of service, maybe modernizing Grand Central Dispatch from 2017. We'll throw that in the chat. It's a very interesting one. You definitely don't need to watch it unless you know you need to watch it, basically, in terms of like, I'm going to be doing some serious queuing stuff. Like the stuff that we've covered is, we're in like, 99.5 percentile of things that you're probably going to use day to day, unless you get into some heavy duty like data processing or something like that.
Yeah, I wanted to highlight that. Is your first two examples that we did, those are the real world. Like I use those every day, whereas the example we just did with the math, it's important to know. It's good to know, especially for like interview questions. Someone's going to ask it, I'm sure. But the number of times you are going to do it,
Yeah, exactly. It's the kind of thing where it's nice to know what's possible, especially when you run into weird problems, where just know like, oh, something queues, let me go watch some videos and remember how to do this for the times when you actually need to. But yeah, it's definitely more for sort of interest in esoteric cases at this point.
Are there any other questions in chat? Because we're kind of getting towards the end of this session. Is there anything else, Zev, that you wanted to touch upon?
I think that's the basics. This is fun, and as we said at the top, or for people who missed it, we did this session because a lot of people mentioned threading and concurrency when we asked what people wanted to learn. I know animation is another one that's been mentioned a lot, so I think we're talking about doing one of those. Keep those coming. Send us requests on the Slacks, because that's directly where we take our ideas from.
Abbott MG read an article about performance traps on iOS, and it mentioned that iOS will just keep making threads of concurrent queue. Of a concurrent queue has more work. Have you seen that happen? I think we saw it just now with our example, right? Where until you or when you had specified a single queue being not concurrent, it stayed in one place, whereas as soon as you made it concurrent, it spun up a whole bunch of threads, and so it just kind of goes.
Yeah, I'm not sure. I mean, if you're talking about, I'd love to see. I think I know which article you're talking about, but I am not able to find it. I remember seeing this Medium post by like somebody who used to work at Apple. If that's the one you're talking about, please post the link if you have it handy.
I don't know if people can post links in my chat. Oh, well, you're doing it, so yeah, people can post links in my chat.
Okay. But if you can't post a link, just put spaces so it doesn't look like a link. Yeah, I don't know of specific issues other than like the stuff I was talking about with mail, where you're like writing threads yourself. It's possible that there are issues with sort of thread profusion and thread starvation when you end up with too many threads. I haven't worked in such like performance critical environments that I really had to worry about that. But don't just go into threading and queuing on the stuff that I've shown you. Like for simple networking, yes, but for anything more complicated, definitely do a little bit of reading, watch WWDC videos. They do a really good job of laying out what's possible and what's important. So I definitely recommend those for further reading.
Super
And it
quick,
looks like,
because it
yep.
is a pretty detailed topic. Can you just like touch upon memory leaks?
Oh yeah, totally. First of all, let me just see if this was the, yeah, this is the post I was talking about. So this is posted in the chat, and creating threads doesn't come for free. If the block you're working on, oh yeah, if you do a whole bunch of threading for small tasks, there's a little bit of overhead for creating queues. So if you're doing a bunch of tiny tasks, basically don't bother with queuing. And that kind of gets to what I was saying at the beginning of like, write it the slow way first. Don't assume you're going to need to do backgrounding and threading and all this stuff. Write it on the main thread and see how it is. Try it on device. Make sure your app is responsive. If it's not, then that's the time to start looking at backgrounding, and probably not before.
Yeah, I usually
Yes.
don't. I usually don't spin up a queue until I see something unexpected, and
Yeah,
then I'll
exactly.
toss a few breakpoints around, and then see what's looking weird, and that's when I'll start bringing in queues.
Yeah. So the question about memory leaks, yes, great point. I forgot to bring it up. So you do often see concerns about memory leaks posted on various places when they're talking about queues. You will often see, I think the most common thing is this weak self dance. So the short version of that is that queues are objects. I don't know if they're literally like class. Oh yeah, so queues are classes, and when you, I guess more to the point, closures are classes basically. They hold owning strong references to everything inside them. So like when I reference self inside this queue, uh, as long as this closure exists somewhere in memory, then it will keep self alive, whatever self is. In this case, it's my view controller. You'll see a lot of people just putting weak self or unowned self everywhere, and that would break a memory leak if there is one. So if I do weak self, and then this would be self question mark, now this closure doesn't keep self alive. So if self happens to disappear and it gets to this closure, it'll just, oh, it's nil, I don't do anything. But you don't always need to do it. The only time when you need to actually worry about that is if you actually have what's called a retained cycle, where two different things are keeping each other alive. So just very briefly, that would be like, you'll see this a lot if you have some view controller. Give me my pen tool. So you have some view controller, and it has a bunch of objects, and one of those is like some callback closure. So that's a closure property that it owns, and you're going to set it to some value, and then later you're like, hey, please call me back when you get your answer of whatever you're doing. So you have that callback closure, and you set it to some closure, and then in that closure, you reference the view controller to something. So now the view controller owns the closure, and the closure owns the view controller. The closure is going to keep the view controller alive, and that's where you would want to do a weak capture of the view controller or whatever thing you're dealing with. So basically, if you can draw a diagram like this and you have those arrows pointing in both directions, where the one thing is keeping the other alive and the other is keeping the first thing alive, those are the only cases where you need to use weak self. So why didn't I use weak self in basically anything I did tonight? Well, I never, in none of my examples, did I have something like callback, which is something that takes an int and returns void, something like that, whatever, like some answer. I didn't have any of those. I was never setting a closure somewhere and having that stay alive. So if we look at this example, our view controller owns the math queue, and then inside this piece of work owns our view controller. And you think, well, wait a second, isn't that a cycle? Can't you draw the diagram with the arrows pointing both ways? Yes, but I know that this piece of work is short-lived, and it's only gonna exist and keep the view controller alive as long as it takes to do that math. And I happen to know that the math while expensive, doesn't actually take that long.
Also, your view controllers won't be unloaded because they are the tab bar.
Yeah. In this app, I never have to worry about unloading specific pieces of the app. And then the most common case, our old friend dispatch main. This is always going to run the next time the run loop ticks over. I know we didn't talk about run loops, but like the next time the app does a thing, on a sort of 60th of a second time scale or faster, it will flush through any work that is queued up on the main queue. And so it's generally okay to reference self inside stuff on a dispatch to main, because while the work on the queue owns self does not own the main queue. It's the main queue, and that work is not going to live for very long. Even with network operations, those are the longest lived operations that we had this evening. Well, this was all async, so that doesn't matter. But in the actual place where we called it, we did our get quotes, and we didn't do a weak self in here, even though self is referenced all over the place, because I know that success or failure in a maximum of my timeout's probably like 10 seconds or 60 seconds or something, and as soon as either the request comes back or it times out after that amount of time, either way, this block is getting called, this block is getting called, and then it goes away, and nobody's owning it anymore, and everything inside it is released. So there's a lot of sort of FUD, fear, uncertainty, and doubt around when you're supposed to do weak self. But for many of the common use cases in closures, you don't, and you only do when you're owning the closure, or if you really care that like some long running piece of work shouldn't keep your thing alive. I will caveat that with one thing, which is if you have a timer that's a repeating timer and it has a block, since the timer is repeating, it will never release that piece of work, that closure that you passed in, until you tell the timer to stop. So if you need a timer that will stop when it's owning, like view controller goes away, then you need to do a weak self there. One little caveat for you.
Cool. So I think this is where we're going to end the stream, because we've been going for 2 hours and we've covered the topics. And also my dog desperately needs to go out.
Me too.
So I want to thank everyone for coming checking out the stream. I want to thank Zev for doing this amazing presentation. I said on Twitter, I just made a fake little server that gave back automatic responses, and you built this entire app with all these great examples in it. So huge thank you. If you are in the greater Boston area, we do this meetup on the third Thursday of every month. And for the foreseeable future, probably will be in a format similar to this, unless things change with the way the world is going. So keep an eye on Twitter. That's where we post most of our updates. The meetup has a Twitter, which is LearnSwiftBOS. You've seen my Twitter going. It's at mdiasdev, and Zev on Twitter is Zev Eisenberg. So yeah, thanks again, everyone. Oh, I also want to say real quick, we got a bunch of new followers during the stream. So thank you, TASU, Captain Gary, Eve Lardiez, Pikinam, Dragon Dust, and Dej Vi. I do these streams without Zev, unfortunately, on Tuesday evenings at 7:30 p.m. and Saturday afternoons at 1:30 p.m. all times Eastern. So yeah, thanks for watching the stream. Maybe Zev will hang out and chat once we both had a bio break. But again, thank you all for watching, and I'll see you next time.